Good afternoon, all of you. Am I audible?
Yes, ma'am.
Yes, ma'am.
And whether the screen is visible to you?
Yes, ma'am.
Okay. Okay, so we will wait for 2-3 minutes because only 51 participants are there. We will wait for 2-3 minutes and then we will start. Okay, so let us start. So we have started with unit number 3, geometric transformation. This is the syllabus. And in 2D transformation, we have seen translation, rotation. Then we have seen scaling and its types. And we are now currently learning reflection, right? So few things we have learned about reflection. So reflection is nothing but which produces the mirror image of the object about the specified axis. So that axis is acting as your mirror and you are going to get its mirror image on the opposite side of the axis. So this is how the reflection takes place. So this is a triangle given and we have seen the reflection is along x-axis. So the reflection along x-axis is specified as every y coordinator is going to change and only in its sign. So magnitude of y coordinator is not going to change, only the sign of y coordinator is changing. So reflection is nothing but the mirror image in which the rotation of the object is observed by 180 degree. So whatever the axis is given to you, it may be x-axis, it may be y-axis, it can be y equal to x or it can be y equal to minus x. So we have the reflection about these 4 axes. And reflection is always acting as a mirror image and it is same as that of rotating the object by 180 degree about the specified axis. So 180-degree means either you can rotate it clockwise or in anti-clockwise direction. Both will give you the same result as the rotation is 180-degree about the specified axis, right? So that is about reflection. Then we have seen the reflection matrix, T matrix along x-axis. So we have seen the x parameter is not going to change, only the sign of y parameter is changing, and that's why your T matrix is 1, 0, 0 and -1. So that is about reflection about x-axis. Now in the same manner, we are having the reflection about y-axis. So as you are observing in this diagram, what can be the reflection about y-axis? So here, if you observe, this is the triangle before reflection, that is the original position. This is your y-axis. And whenever the reflection is carried out, 180-degree rotation takes place about the specified y-axis. And the y coordinator is going to remain same before reflection. Whatever the y coordinator is there, that remains same after reflection as well. But what happens with x coordinate? So if you see here, the x coordinate here is negative, and after reflection, we are going to get the x coordinate positive. So in case of reflection along y-axis, y remains same, and that's why this factor, which is responsible for the multiplication with y coordinator. So this remains same, only the sign of x is changing, and that's why -1 come at this location, the diagonal elements which are actually responsible for xy multiplication. So here, in case of reflection along y-axis, x changes in its sign, whereas y remains as it is. The magnitude of x is not going to change, and that's why we are going to multiply it with 1. Only the sign is changing, and that's why we are taking -1 for it. And this is the T matrix for the reflection along y. So let us see whether we are going to get the same T matrix for all possible combinations. Okay, so just now we have seen this type of reflection. Let us see what will happen if the point is here or object is here. So object here is only a point which is having x and y values as, let us say, x is positive, so x is 5, and y is negative, y is -5. So this is x is 5 and y is -5. So -5, that is along negative y-axis. Now, let us check whether this T matrix is applicable to this point also. So for that purpose, what we will do, we will take this x and y in one's bracket, and we will perform the multiplication. So it is the matrix multiplication carried out. So this is your P, that is the original point. This is your T, that is the reflection matrix along y-axis. So I will say that Ty for your understanding, that is reflection is carried out along y-axis. And I will have here the T matrix, which is changing in its x value. When reflection is along y, y remains as it is, and x changes in its sign. And now, perform the multiplication. What is the result you will get? 5 into -1. So it is -5 plus 0. Then this row and second column. So 5 into 0 will be 0 plus -5 into 1, that is -5. So I am getting this particular coordinates of the point after reflection. So this is your P dash, the point after reflection. So let us plot this point. So minus minus, both x and y are minus. That's why it will lie in third quadrant. So it will lie somewhere over here. So I will say this is your resultant point after reflection with y-axis. So is it true? Yes, it is having the, it is same as that of the mirror image along y-axis. So I will be getting the point with coordinates -5, -5. So always remember, when I am having the reflection about x-axis, y changes in its sign, x remains constant. And when the reflection along y is there, then y is constant, x changes in its sign only. Magnitude remains as it is. So that is how the reflection is carried out. Okay. Up to this, is there any difficulty? Reflection along y-axis, all of you are understanding it?
Yes.
Okay. Girls?
Ma'am.
Okay. So this is reflection along y-axis. So two types of reflection we have learned: reflection along x, reflection along y. Now the third type of reflection we are going to learn, that is reflection with y equal to x line. So y equal to x line we already know. We have drawn this line so many times, y equal to x line, right? 1, 1, 2, 2, 3, 3 points. 1, 1, 2, 2, 3, 3 points. Okay. So this is your y equal to x line. So I will extend it so that it will be more clear to you. Okay. So this line is y equal to x. Now my question is, am I audible, students?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So here y equal to x line is there. Now my question is, this is my point. Let us say, okay. So what can be the coordinates of this point? 5, 10. X value is smaller than that of y value, right? So x is here. Okay. X is 5 and y is 10. Okay. Now, where the reflection of this point will lie? Can you tell me in which quadrant? Reflection of this point will lie in which quadrant?
Third.
Third quadrant. Okay. Is there any other guesses?
Fourth quadrant.
Fourth quadrant. Okay. How many of you will say first quadrant? Okay. So what exactly is reflection? What exactly is reflection? Reflection is the mirror image of the point where this line will act as a mirror. ही line आहे ती तुमचा mirror म्हणून act होतीये. This color is not looking good. Okay. This line y equal to x is acting as a mirror, and you are going to draw a perpendicular on that line and extend it on the opposite side. तेच करताय ना तुम्ही? तुम्ही काय करताय? See here, when the y reflection is there, reflection along y axis, what you are doing? You are actually trying to draw a perpendicular on this y and extending in the opposite side of y. बरोबर आहे. जेव्हा मी x बरोबर त्याचं रिफ्लेक्शन घेते तेव्हा काय करते, I am going to draw a perpendicular on x and expand it on the opposite side. In the same manner, this point also I will draw a perpendicular on this line and extend it on the other side. So this will become your reflection of this point 5, 10 with respect to y equal to x axis. All of you are clear with this now?
Yes, ma'am.
Right. So now always remember the reflection lies not always, but here if the point is in the first quadrant, its reflection lie in the first quadrant itself. Then what can be the coordinates of this point? What can be the coordinates?
10, 5.
Right, 10, 5, very correct. So the coordinates of this point will be 10, 5. After reflection, x becomes y and y becomes x. So this is the resultant of the reflection about y equal to x. So as you know, x becomes y and y becomes x. Can you tell me the T matrix for it then? You have to change x into y and y into x. For that, what could be the T matrix? Here the sign is not changing and magnitude is interchanging, we can say. Here the sign is not changing, positive remains positive, and the magnitude is interchanging. So I can say the T matrix is like this. The off diagonal elements will be 1 and the diagonal element will be 0, where x will become y and y will become x. So simply I am changing the or I am taking the x replacement by y and y replacement by x, and that's it. I will get the result. So try it for 5, 10. So when 5, 10 is multiply with this T matrix, check the result. 5 into 0, 0 plus 10. So the resultant will have 10 first. Then 5 into 1 plus 10 into 0. So the second point is 5. So ultimately I am going to get the resultant as 10, 5. So this is the T matrix for reflection along y equal to x. Getting it, all of you? Reflection along y equal to x axis. Is there any difficulty? Yes?
No, ma'am.
Okay. Now my question is, suppose I am having one point in third quadrant. I am having this point in the third quadrant. Let us consider the coordinates of this point as 15 and 20, minus 15 and 20. Okay, minus 50, 20. So y value is 20 and x value is minus 15. Okay. So let us see whether the same T matrix will be applicable for this point to get the reflection along y equal to x. हाच same T matrix useful आहे का y equal to x चा reflection check करण्यासाठी? So I will draw a perpendicular again on it and I will extend it on the other side. Okay, so this is your point after reflection. So just check whether you are going to get the same result. So minus 15, 20 into this T matrix. So I will write here minus 15, 20 into this T matrix. So what is the resultant you are going to get? Minus 15 into 0, it remains 0, and plus 20 into 1. So you will get 20 over here, and minus 15 into 1, that is minus 15 plus 0. So here it will remain minus 15. So ultimately I am going to get 20 and minus 15 point as a resultant after reflection. So what are the coordinates of this point? X is 20 because X is positive now. X is 20 here. And Y is negative. And Y value is minus 50. So the point is lying on the fourth quadrant. The reflection of point in the second quadrant will lie in the fourth. And what happens with the third quadrant? So if the point is here, then the reflection will lie somewhere here, and it is applicable to the situation here. So the third quadrant point will lie in the third quadrant itself. Only X and Y gets interchanged. Same as this case, 5 becomes 10, 10 becomes 5. Similarly, here also the same case will appear. Okay. Getting it? So you have to remember all these T matrices. Yes, starting from the translation itself. What are the T matrices for every operation that you have to remember? So let us see the next, that is reflection with respect to Y equal to X. So that is the reflection we have received, and we have got this T matrix already. So Y becomes X and X becomes Y. That is the change in this, that's original changes into the resultant one with this T matrix. Okay. So this is reflection along Y equal to X. Same is, then what will be the case with reflection along Y equal to minus X? Now you tell me. Reflection along Y equal to minus X, the fourth possibility of reflection, where the Y equal to minus X line is, from which quadrant it will pass.
Second and fourth.
Right, it will pass from second and fourth. So this is your Y equal to minus X line. Y equal to minus X. Okay, Y equal to minus X line is this. Now my question is, what will be the, consider any point. Sorry. So consider any point. Okay, this point. Now for this point where the reflection, consider this point is 10, 5, X is 10 and Y is 5. Okay, this is 10, 5. So can you tell me, if I want to reflect it with Y equal to minus X, where the reflection will lie?
Third quadrant.
Yes,
Third quadrant.
third quadrant, right? Correct. So reflection will lie in the third, same as that of the previous case. I have to draw a perpendicular on this line and extend it in the other direction, opposite direction. So here it will be the reflection. And what will be the coordinates of this point?
Minus 10, minus 9.
It's opposite. Minus 5, minus 10. So you will be getting a point where X value is minus 5. You can observe it here very clearly that X is after reflection, the distance of this point with respect to X and Y. This distance is smaller and this one is bigger. That means X value is less and Y value is greater. So which modification is taking place after reflection? What happens with X and Y coordinates? What happens with the magnitude and what happens with the sign of the number?
It changes the magnitude.
Yes, it interchanges, I can say more correctly, right? It interchanges the magnitude. X becomes Y and Y becomes X. So it interchanges the magnitude, that is one thing. And second thing is it changes its sign as well. Positive becomes negative. Okay, so both signs are also changing. X is also changing its size, sign, and Y is also changing its sign. So now can you tell me the T matrix of it? We will go step by step. If I want to interchange the X and Y values, as this case, Y equal to X, it is interchanging the Y and X. So what is the T matrix? We know the T matrix is 0, 1, 1, 0. 0, 1, 1, 0. So this is the T matrix for interchange operation. So with this, what you will get? The earlier 10, 5 will get converted into 5, 10. Okay. Now, what is your next mission? That you have to change the sign of them also. So sign of them can be changed easily if I add only minus sign. So this will change the sign of Y. This will change the sign of X. That is earlier X and earlier Y. Okay. So this is how your T matrix will be for Y equal to minus X axis reflection. So let us see whether we are going to get the same result. So when I am going to multiply 10 with 10, 5 with this T matrix, what is the resultant I will get? 10 into 0, 0 and minus 5 here. Similarly, 10 into minus 1, that is minus 10 plus 0. So I am going to get the point after reflection. So this is how the reflection takes place along Y equal to minus X axis. Now suppose the point is here. Suppose the point is here. So what are the X and Y coordinates of this point? Suppose X is 10 and Y is 20. So this point is X is having value, X is negative. So it is minus 10 and Y is positive. So 20. So after reflection, what will be the resultant coordinates of the point?
Minus 20, 10.
Minus 20, 10. Okay. So whether this same T matrix you are applying on it? Yes, no? Because this is the T matrix applicable for all reflections with Y equal to minus X. We have derived this already. So 10, 20, I'm going to multiply it with 0, minus 1, 0. And then I will be getting the resultant thing, that is minus 10 will get cancelled over here. You will get minus 20. So there is interchange in the sign as well as magnitude interchange. So here 10 into minus 10 into minus 1. So 10 becomes plus and 20 into 0, 0. So you will get minus 20 and 10. And where this will lie? This will lie here, where y is half of this distance. Here it is 20. So it will be here somewhere 10. And this is your x minus 10. Here somewhere it will be minus 20. So this is your minus 20. So these both points, wherever they will intersect, you will get the point. So this is the reflection of point with respect to y equal to minus x-axis. Getting it now? All the 4 types of reflection. So we have learned 4 reflections along x-axis, where y will change its sign. Along y-axis, where x will change its sign. Along y equal to x, at that time y become x, x become y. And along y equal to minus x, interchange plus sign change of both xy parameters. So that is the reflection along 4 specified axes. Okay. Is there any difficulty in the reflection? If you are not getting anything, ask me right now, or we will move to the next point. Is there any difficulty?
No, ma'am.
Okay. So let us start with the next point. So reflection part is over. And now we are going to start with the 5th transformation, that is shearing. Okay. So what is shearing? Shearing is nothing but the size of the object is going to change along x or along y. So you are going to change the size of the object along x or along y. Then depending upon this change, size change, there are 2 versions of shearing, that is shearing along x direction and shearing along y direction. Shearing along x direction and shearing along y direction. So size change we have observed in which transformation?
Scaling.
Scaling, right? Very correct. So in scaling we have seen size is changing. In other, except scaling, the size is not changing, only the place is changing, right? Only the location is changing in all other remaining things. So here the scaling is done by the diagonal elements in the T matrix. We have already, I have told you that this is the favorite question of the examiner, that the diagonal elements are responsible for scaling operation. Okay. And for shearing operation, the off diagonal elements are responsible. So these 2 elements, the off diagonal elements in the matrix, are responsible for shearing. Now, in case when these 2 are non-zero, in almost all the transformations we are getting these 2 elements as 0 only. But if they are non-zero elements, then we are going to observe the shearing in the object. Shearing is nothing but simply stretching the object along x-axis or stretching the object along y-axis. Like a simply I am consider a flexible object, flexible square that you have taken into your hand, and you are pulling it along x-axis. You are pulling it horizontally. So its size is going to change. Elastic object, if any elastic object is there, and you are going to apply the pull on any side of that object along x-axis. जर तुम्ही एखादं इलास्टिक ऑब्जेक्ट हॉरिझॉन्टली पुल केलं तर जो काही डिफॉर्मेशन होतं त्या ऑब्जेक्टमध्ये, त्याच्या शेपमध्ये, साईजमध्ये, दॅट इज कॉल्ड ॲज शिअरिंग. सो शिअरिंग is achieved in x direction or shearing is achieved in y direction. Okay, so that is and these off diagonal elements are responsible for them. Okay, so let us see how the shearing takes place. So consider any object where x and y are the original coordinates. So old represents the initial coordinates of the point. So a point is there, any point with x and y value, x old and y old. Then shearing parameter toward x is given as SHX. SH stands for shearing along x-axis, and here for y direction we are going to call it as SH along y. So SHX and SHY are the shearing elements. Then new coordinates are x new and y new. New coordinates are x new and y new. So shearing in x-axis, how we are going to represent that? As we have already discussed, this x-axis shearing is achieved, or any shearing is achieved by the off diagonal elements. So if you want to observe it in x-axis, which element should be non-zero? In this T matrix, which element should be non-zero? Suppose this is your original value, x old and y old. So x old and y old are these two values. And now I want to observe x shearing in x direction. That means some value should be added into x. These diagonal elements are always 1 in case of shearing, and off diagonal elements are non-zero. So here the off diagonal elements are non-zero and I want to achieve the x shear in it. That's why this parameter is responsible for shearing along x-axis. How? Because if I multiply with this x0 into 1, it is x0 plus SHX into y0. So I am adding some value in my original x. While y remains constant. X0 into 0 is 0 and y0 into 1 is y0 as it is. That means as x is changing, I am observing the shearing effect along x-axis. Similarly, if I want to achieve the shearing effect along y-axis, I have to keep this element as non-zero, SHY, and this element as 0, so that when I multiply with this, when I multiply the original point with this, x0 will remain as it is, but I will observe some addition in the y0 plus x0 into SHY. So I will add some value into your original y value, and that is nothing but shearing in y-axis, y direction. Okay, so always remember the off diagonal elements are responsible for shearing, and shearing is of two types: shear along x-axis where some amount is getting added into original x. The second type is shearing along y-axis, so some amount is getting added into the original y coordinate. So this is called as shear along x and shear along y. So this is the expression x new. What is new x? It is original x0 plus SHX into y0. So SHX into y0 or y old. So x has been modified where y is as it is. And in the next next type, you are going to have shear in the y-axis. So how the y-axis shear takes place? So here you are going to have SHY, which is non-zero quantity. Getting it? You are observing here the exactly opposite is the case, because you are taking x and y as your column values. If I am taking row values, then this is the correct output. If you are going to take the column values, then simply you have to transpose your T matrix. Okay, so that is how shearing will take place. That is some amount of addition in either x or y. That is called as shear along x and shear along y. So this is the T matrix you have to remember, these two. Okay. So what happens with the diagram actually? What happens with this shearing? So let us see it on one square. Let us apply it on one square. Okay. So this is the square of size 5. This is square of size 5 each. So this is your, can you tell me the coordinates now? The size is 5. That's why this is 0, 0 origin. This is 5, 0. This is 0, 5. And this is 5, 5. Okay. So this is the square. And now I am going to apply the shearing along x-axis. So shearing along x-axis. So consider the object square and apply the shearing along x with a factor 2. With a factor 2. So the factor, that is shearing factor, is given, and that is equal to 2. So I am going to replace this SHX by 2. Okay. So this is the T matrix for shearing along x-axis with a factor 2. And now I will write down my original P matrix. So this is your P, where the square is having the elements at 0, 0, then 0, 5, then 5, 0, and 5, 5. Okay. And now I'm going to multiply it with this T matrix. So this is the T matrix for the shearing along x-axis with a factor 2. So after multiplication, what is the result you are going to get? 0 into 1, 0 plus 0. So here, as 0 is getting multiplied, there will not be any change in the first particular point. So it will be 0 as it is, 0, 0. Next, 0 will be as it is. So 0 into 1 plus 10. So I will be getting here 10. Similarly, 0, 0 and 5. So 10, 5 is the next point. That is after shearing. Next is 5, 0 when multiplied with this matrix. So 5 into 5 plus 0. So 5 and 0, 5 into 0 and 0 into 1. So you are going to get 5, 0 as it is. Next is 5, 5. So 5, 5 in that 5 plus 10. 5 plus 10, it is 15. And 5 into 0 is 0 plus 5, it is 5 itself. So I'm going to draw this object now. So 0, 0 is the same point. Okay. Next is 10, 5. This is 5 y value and 10 is somewhere here. So 10 and 5. Next is 5, 0. So 5, 0 is here itself. And the next point is 15, 5. So 15 is here and 5 is here. So this is your first point, 0, 0, which was earlier the same. 0, 5 has been turned into 10, 5. So 0, 0 to 10, 5 is my first point, first line, sorry. Then 5, 0 as it is. So this particular thing is not going to change. And 15, 5 is the last point. So this is your object. So if you see, there is deformation in the object by keeping this side same, but stretching along x-axis only. There is no change in the y. The height of this is still 5. If you can observe, the height of the object is 5 itself. Only there is deformation in the x direction, and that's why we are changing the size of the object by applying shearing on the object itself. Getting it? And the same is done if vertical, I am going to apply it on, that is shear along y-axis. So what can be there if the shear is along y-axis with a factor 2? So this value, which is a off diagonal element, will become 2, and this will be 0 because there is no change in the x direction. And you can carry out the multiplication and plot the result. So after multiplication, I will be getting 0, 0 when it is multiplied with it. You are going to get 0, 0 itself. 0, 5 into this. So 0. And this remains at 0 only. And 0 and 5. So 0, 5. Next is 5, 0. So 5 into 1 plus 0, that is 5 and 10. So it will be 5, 10. And the last one, 5 into 1, 5 plus, sorry, this T matrix. 5 into 1, 5 plus 0, that is 5. And after the second, this row and second column, that is 5 into 2, 10 plus 5, that is 15. So now see here, as the shearing is along y-axis, your x is same, 0, 0, 5, 5, 0, 0, 5, 5. X is same here, only y is changing. So first point is 0, 0. I will use some other color.
Hello, ma'am.
Yes.
Ma'am, तुम्ही PPT वरती वेगळं दिलंय वरती. Sharing along x-axis.
हा, मी त्याचं कारण पण सांगितलं होतं एक्सप्लेन करताना, की हे मी घेतलंय ते तुमचं रो वाईज घेतलंय का कॉलम वाईज घेतलंय त्याप्रमाणे तुम्हाला ट्रान्सपोज करावं लागेल, हे मी बोलले होते. आता मी कशी घेतेय, रो वाईज घेतेय ना, हे एक्स आणि वाय एका रो मध्ये आहेत म्हणून हा टी मॅट्रिक्स आहे. हे जर तुम्ही कॉलम मध्ये घेतलं म्हणजे रो व्हेन बिकम कॉलम, देन ऑब्व्हियसली ते पण तुम्हाला ट्रान्सपोज करावं लागेल ना.
Yes, ma'am.
येस, कळलं आता डिफिकल्ट चेंजेस काय
Yes,
आहेत?
yes.
Yeah, okay. Because I am taking xy in row, that's why this is your T matrix. But if I will take in a column like fashion, then obviously you have to transpose your T matrix also, and it will be row become column and column will become row, like that, nothing else. Okay, so just let us plot this new diagram, 0, 0. is the same point. Again, I will be getting, it is not showing any difference in the color. Actually. White. Okay, white will do. Okay, good. So this is 0, 0. Then 0, 5. 0, 5 is here itself. Okay. Then 5, 10. 5 and 10 here. And next is 5, 15. 5 and 15. Okay. So I'm going to get the object like this. So there is change in the, there is deformation along Y. So here is the shearing of this original object. Now all of you are getting about shearing along X and shearing along Y. Yes. Yes, students. Is there any difficulty? Shearing operation?
No, no.
Okay, girls, all of you clear with?
Yes, ma'am.
Okay. So in up to this, we have completed all the 5 basic transformation of 2D: translation, rotation, reflection, scaling, and shearing. So these 5 transformations we have learned for 2D object, right? The next point in your syllabus is combined transformation. Next point is combined transformation in your syllabus. So as the name suggests, what is combined transformation? Combined transformation, right? So the next bit is combined transformation and rotation about arbitrary point and reflection through arbitrary line that we will see in the next lecture. But let us concentrate on combined transformation. So what do you understand with combined transformation? Okay, so before we go to the combined transformation, let us see shear transformation in detail. So it is nothing but it distorts the shape of the object. Like, because earlier we have seen the example of square, and after shearing, no longer it look like a square. It has completely deformed its shape. So shearing transformation always distorts or deforms the shape of the object. So it changes the shape and along x-axis or along y-axis. That's it about the shearing. So here they have shown it, shown with the diagram for the triangle, shearing along x-axis and along y-axis. So we have seen it for a square. So it is same case. Okay. So it, always remember this MCQ type of question that due to shear, the shape of the object get deformed, or it can be said like shear is the due to off diagonal elements. So you have to remember all these points, that deformation takes place in size, shape, and it changes the size of the object, and it is due to off diagonal elements. Okay. So let us see some of the combined transformations. So combined transformation is nothing but number of transformations when applied on the same object. आतापर्यंत आपण काय बघितलं, फक्त एकच ट्रान्सफॉर्मेशन ऍट अ टाइम पाहिलं ऑब्जेक्ट वरती. पण आता जर मी असं म्हटलं की अ ट्रायंगल इज गिवन टू यू, you have to first rotate it with 40 degree then reflect it with x equal to y, y equal to x axis, and then translate it to 3 units left and 4 units bottom. असा जर प्रॉब्लेम असेल तर ऍट अ टाइम तुम्हाला किती ट्रान्सफॉर्मेशन्स त्याच्यावर करावे लागतील? फर्स्ट मी म्हणते रोटेशन विथ 40 डिग्री, राईट. सेकंड मी म्हणते रिफ्लेक्शन अलॉंग y इक्वल टू x, and third is translate the object to the 3 units to the right and 4 units down. बरोबर. So 3 transformations are applied on the same object. जेव्हा असं असतं तेव्हा तुम्ही काय करणार? हा दिलेला तुमचा एक ABC चा एक P मॅट्रिक्स असेल, ओरिजिनल मॅट्रिक्स. त्याच्यावर तुम्ही पहिल्यांदा T रोटेशन कॅल्क्युलेट करणार. त्याच्यावर पहिल्यांदा तुम्ही T रोटेशन करणार, बरोबर. त्याचा काहीतरी एक येईल P डॅश. त्या P डॅश वरती तुम्ही परत T रिफ्लेक्शन ट्राय करणार. त्याचा परत एकदा येईल P डबल डॅश. त्याच्यावरती मी T ट्रान्सलेशन ट्राय करणार. ओके, दिस इज युअर steps, moves, how you are going to proceed. So first you are going to apply the rotation, then you are going to apply the reflection, then you are going to apply the translation. मग प्रत्येक वेळी P घ्यायची गरज नाहीये. आता इथे तुम्ही काय करताय? P इंटू T रोटेशन. त्याचा जो काही रिझल्टंट येईल P डॅश इंटू T रिफ्लेक्शन. त्याचा जो काही रिझल्टंट येईल तो असेल P डबल डॅश त्याच्याशी T ट्रान्सलेशन. प्रत्येक वेळी एवढ्या मल्टिप्लिकेशनची गरज नाहीये. त्याच्याऐवजी कंबाईन ट्रान्सफॉर्मेशन मध्ये काय होतं? तर कंबाईन ट्रान्सफॉर्मेशन will give you the final T matrix. So I will call it as a T total. T total. मग तो T total काय करेल? तर T total will perform the transformations, multiplication, the product of all the transformations first. So this is your first transformation, but always remember you have to follow the order of the operation. जसं दिली आहे ऑर्डर की पहिल्यांदा रोटेशनच करायचे, नंतर त्याचं रिफ्लेक्शन घ्यायचे, नंतर त्याचं ट्रान्सलेशन घ्यायचे. So you have to follow the proper order of the operation, then only the correct result will be correct. Otherwise you will get a wrong outcome. So T total, you have to follow the sequence of the ट्रान्सफॉर्मेशन्स. सो मी पहिल्यांदा काय करणार आहे? हा पहिला जो T मॅट्रिक्स असणार आहे तो माझा T रोटेशनचा असणार आहे. दुसरा असणार आहे तो T रिफ्लेक्शनचा असणार आहे. आणि थर्ड T मॅट्रिक्स विल बी फॉर माय T ट्रान्सलेशन. याच सिक्वेन्स मध्ये जर तुम्ही त्याची मल्टिप्लिकेशन कॅरी आउट केली तर तो तुम्हाला मिळेल T टोटल. आणि मग नंतर मी काय करणार आहे? सिम्पली द ओरिजिनल P I will multiply it with T total and I will get directly output P double dash or P triple dash. हे P double dash into T translation होता आणि त्याचा रिझल्टंट येत होता इथे P triple dash. तो मला डायरेक्ट मिळेल इथे. का तर मी T total हा ऑलरेडी त्याचं ट्रान्सफॉर्मेशनचं कंबाईन करून टोटल ट्रान्सफॉर्मेशन, कंबाईन ट्रान्सफॉर्मेशन I am getting it with this T total. Now my job is simply apply this total transformation on your original object. मग त्यामुळे काय होईल? तुमच्या 2 स्टेप मध्येच रिझल्ट येईल. पहिलं तर T टोटल फाइंड आउट करायचं या मल्टिप्लिकेशननी आणि नंतर फक्त P ला T टोटलनी मल्टिप्लाय केलं की तुम्हाला तुमचा टोटल रिझल्टंट P ट्रिपल डॅश मिळून जाईल, एवढे स्टेप वाईज कॅल्क्युलेशन करण्यापेक्षा. ओके, सो दिस इज हाऊ the combined transformation is applied on the object, but order of the operation should be preserved. आपण एक एक्झाम्पल बघूयात नेक्स्ट लेक्चर मध्ये, ज्याच्यामध्ये जर आपण ऑर्डर इंटरचेंज केली तर काय होईल ते पण आपण बघूया. सेम रिझल्ट येतोय का नाही येत ते. ऍज द मल्टिप्लिकेशन is non-commutative, you may get the different dimensions of the T matrix for that. Okay, so here you are going to follow the order in a proper sequence, then you will get the accurate result. Getting it? So in combined transformation, what you have to do is follow the sequence of the transformation, perform the multiplication to get the T total. That is all the transformations together, and then simply perform the product of original P into that T total, and you will get the resultant as the output. Clear up to this? Yes, students?
Yes, ma'am.
Okay, right. So as the time is up, is there any difficulty? Those who have not understood anything? Any point if you are not understanding? Okay, so for today we will stop here. And in the practicals tomorrow we will learn, we will complete the last time practical also, that is the circle generation algorithm and polygon filling also. So we will complete both the tasks tomorrow itself. Okay, so we will stop here. Thank you.